Hi, I'm Brian Arthur. I develop products at KVH Industries where we design, test, and manufacture antennas for mobile satellite communications and entertainment. We're here in KVH's new test facility. We recently used this facility to develop our HD11, a 1-meter TV antenna designed to provide TV reception anywhere in the world on any vessel. To give you some background about testing antennas, you need to know that satellites used for television and broadband communications orbit the Earth above the equator in an area called the Clark Belt, where they travel at the same rate the Earth rotates, so they appear stationary in the sky. Communicating with these satellites to receive television broadcasts or send and receive high-speed data communications requires aiming an antenna within half a degree or so. Aiming an antenna within half a degree can be a challenging proposition from a stationary point on land, and it really becomes a challenge from a vessel getting bounced around in heavy seas. There are two key elements to our test facility. Behind me is a curved wall of windows that provide a full, clear view of the Clark Belt and the satellites that are orbiting the Earth 22,500 miles above the equator. The windows are made of polycarbonate, which ensures a clear satellite signal. The other key element is, of course, our motion table. We call this the hexapod or Stewart table, which allows us to test our products for vibration and motion simulation. The motion table simulates realistic sea motions like those experienced on yachts and commercial vessels during really bad weather. This process helps to ensure that fielded antennas are capable of maintaining a lock on the satellite without any malfunctions due to motion. We test our antennas at 30 degrees tilt and pitch and roll, at velocities up to 45 degrees per second, and accelerations up to 120 degrees per second squared at a 2-second period. When we started the test, the antenna was tracking a satellite at orbital slot 101 degrees. As you can see, the antenna remains pointed at that satellite while it experiences motion similar to that seen on a ship moving violently in a huge storm. This ensures that even though the weather is bad, the vessel can still watch TV or exchange emails or make phone calls. KVH antennas achieve these goals by first tracking the energy emitted by the satellite. The antennas also use multiple MEMS gyroscopes and accelerometers to measure the large changes due to ship motion. The antenna uses software that combines the input from these various sources, calculates the antenna motion required to counteract the ship's motion, and feeds control data to the motors, which are sized to move the antenna as fast as is required to stay on satellite, even in the worst conditions. As you can see, even though the motion is extreme, the quality of the television picture is perfect.